So we're going to do an example algebraically and graphically. So let f of x equal x squared and g of x is equal to negative x plus 1. We're going to create an equation for h of x is equal to f plus g of x. So I'm just going to go over here. H of x is going to be equal to f of x plus g of x. Now h of x is going to be equal to my function f of x is x squared. My function g of x is negative 2x plus 1. You can put that in brackets just to make it a little bit more evident. So I'm adding two functions. The resulting function is going to be x squared minus 2x plus 1. So if we look at it from an equation view, you just simply add the expressions of the functions. From a table view, somebody's been fairly nice and calculated all the y values for a given x values. So we have all the y values for f, all the y values for g. So here, when x is negative 2, we simply add the y values. So for h of x, we have a point negative 2, 9. When x is equal to negative 1, we had a value for f of negative 1 and the value of g of negative 1. We simply add those together and we get another point where the x value is determined by your original input and the y value is your output. Similarly, the value of h of x, where x is equal to 0, is 1. So I know I have a point 0, 1. If I add the y values for f and g, I get f plus g is equal to 0. So I have 0.0 or 1, 0. And there we have it. That's all there is to it. So we maintain our x values and we add the y values. And if you want, we just simply plot these points and we will get the shape of our graph. And I'm going to do that because it's nice and easy. And look at this, right? What shape is this coming to be? It's looking like the shape of a parabola. And if you take h of x, which we did independently, right? It was the set of instructions. Interestingly, h of x has the equation x minus 1 squared. And if you can recall from grade 11, this would have a vertex at 1, 0. And if you look at the graph of h of x, we do have that vertex at 1, 0. So we can construct the graph of the sum of functions either by using a table of values or working off the graph. Although a function is not a transformation, we can construct point notation to describe the sum of functions in the following way. So h of x is equal to f plus g of x, and I've named f and g just arbitrary. But what we see is that f has an xy value at x comma y subscript f. Then the function g would have the point x comma yg. Simply, to get the new point, we would just add the y values of f and g while keeping x the same. These x's are the same. Or in more functional notation, I would use, instead of y subscript f, I could use f of x. And instead of y of g, I can use g of x. to create my functional notation there. Note, it is only appropriate to add two functions f and g of x if f of x and g of x are defined. So, for example, identify, so we're going to consider these two graphs, f, which is the linear, so I'm going to call this f of x, and this g of x. So when we take a look at f and g, what is the domain of f and g of x? Well, f of x, for f of x, the domain is really x's element of the reals. For g of x, the domain is x is greater than or equal to -3. So what is this domain? What is the domain of h of x, which is f of x plus g of x? Well, f of x must be defined and g of x must be defined. In other words, putting it another way, you need to add two y values. And if one y value doesn't exist, you can't add it to the other one. If we look at it from a number line perspective, f has the domain from -infinity to +infinity, so it's everywhere. G has the domain, and it's -3, but it's greater than or equal to -3. Now allow me to switch colors here. So it's equal to -3 or more than. And if both domain for f and the domain for g must be defined, the domain of h of x would be, where are they both defined? And they're both defined where? X exists such that x is greater than or equal to -3, x is element of the reals. So we're going to graph this, and I'm just going to graph this very quickly, and hopefully I won't lose you. I'm going to graph h of x, looking just at the graphs of g of x and f of x. I'm going to take a look, and I'm going to be very careful and meticulous. F of x is fairly easy. G of x is the tricky one. But I'm going to pick out all the points that have integer coordinates. So those are nice coordinates that I can easily add because I know that these are integer y values and x values. And if I take a look here at x is equal to -3, x is equal to -2, x is equal to 1, and x is equal to 6. Now I'm only going to add these because I know the values. I'm going to attempt to graph h of x. So I simply add the y values. So it's f. The f at -3 is -3. The f, or the g of -3 is 0. So really, -3 plus 0 is -3. When x is -2, f of -2 is -2. The g of -2 is 1. So -2 plus 1 is -1. And move to my next set of integer points that I know. The f of 1 is 1. The g of 1 is 2. 1 plus 2 is 3. And my x value stays the same. So far, I have this weird function that looks maybe like this. Now let's see where this one goes, and it's going to get crazy here. The x value at 6, so the f of 6 is 6. The g of 6 is 3. 6 plus 3 is 9. And what I get is my function probably looks something, it's going to have a little bit more curve to it. I really didn't do this too much justice, but I have an overall idea of what it's going to look like. And since this is continuous, my endpoint will also be continuous.